Okay, 7.8, last lesson of the chapter. Radical and exponential functions. All right, so a radical function is one where the radicand contains a variable. We've done this before, but now we're going to graph them. Okay, so I got a general form for a radical function. So you got y equals a. I wonder what that means. Times the quantity x minus, and there's something goes in there, plus, and something goes out there. And we have no earthly idea what these things are. We would have no means of knowing what goes in the rest of the radicand and what goes outside. But if you were to get it, if you were to just simply guess, what would you think would go in the radicand? Of course, it would be h, and outside would be k. Because math is nice and orderly, unlike English, and everything goes together. All right, so h and k, just like with parabolas, just like absolute value, just like everything else we've dealt with. So then the vertex would be hk, because math is orderly. All right, so we can figure out the vertex coordinates from hk. All right, so for a parabola, A would control whether it was steep, narrow, or what was the other term they used? I used wide, but what did they? Flat. All right, steep or flat. Kind of the same idea, steep or flat. Not only A, though, if A were positive, it was what, a max or min? Min. If A was negative, it was a, look what happened. So from a min, it went to a, so that is reflected about the x-axis, right? So I wonder if that's going to be the same as well. All right, so that's what we need to look through as we go along here. All right, so first one. We got y equals just the square root of x. Very, 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 very basic. All right, hopefully you realize this is the exact same thing as if we would have said y equals 1 times the square root of x minus 0 plus 0. Agreed? So what's the coordinates of the vertex? 0, 0. So I'm going to go ahead and plot that point at 0, 0. And you should as well. All right? Put it at the origin, 0, 0. And we really don't even need this first 0. We just did it. Okay, now let's go ahead and sub in 1 for the x value. And the square root of 1 is 1. So let's plot the point 1, 1. And let's do 4. Notice I skipped some values because I'm sticking with whole numbers here. And we all know the square root of 4 is 2. And we'll do 9. And we all know the square root of 9 is 3. And so we have 9, 3. And that's enough that way. So just to think about it, what happens if you use a negative 1? What is the answer to square root of negative 1 is I, which is imaginary. And remember, imaginary numbers are graphed on an imaginary or complex plane. There are no imaginary numbers in a Cartesian plane. They don't exist. So the graph of this thing looks like this. And that's it. So can somebody tell me the values of the domain? What is the domain? We've done this before. Luke?
X is greater than equal to 0.
Correct. X is greater than or equal to 0. That's inequality form. You guys remember how to say it in interval form? Parentheses or bracket? Bracket. What comes next? 0, comma, infinity, parentheses, right? Either way, I'll take it either way. Again, I would start learning interval form, though, because advanced math and calculus deal with interval form. Right? Okay, how about the range? What's the range? Again, you're thinking domain, x values, possible x values. Range, you're thinking possible y values, right? So what's the domain? I mean the range. What's the range? Just say it if you know it. Y greater than or equal to 0. Look, this thing is definitely going right quicker than it's going up. But it's got forever to go right, therefore it has forever to go up. So it will get to infinity eventually. And again, this is the same scenario, bracket 0, comma, infinity, parentheses. And that's the base function. Everything else is a transformation off of this. We could relocate it in the Cartesian plane. We could mirror it about the x-axis. We could even mirror it about the y-axis. We could make it go up more steeply or go up less steeply. All of that control with the numbers involved. All right, so take a look at the second one here. So now you can see it's similar. Get just to there. Okay, so similar function. This time we're going to say the vertex is where? 2, -1, right? The h and k value. So I'm going to go to 2, -1, and I'm going to plot that point. So now, XY chart. So here's an important concept to get you going, just like in parabolas. Remember how we started with the vertex, the max or min point? And that's going to help you to know what value to use next. So because the vertex is at 2, -1, what x value do we want to start with? Say it if you know it. 3. We're already at an x value of 2. Go one more and start at 3. If you use 2, you'll get -1. We already know that. If you use 1, it'll be imaginary. 0 will be imaginary. -1 will be imaginary. Everything else less than 2 is going to be imaginary. So let's use 3. So now again, we're doing the square root of 3 minus 2. That's the square root of 1. And the square root of 1 is 1. And don't forget, you got a -1 at the back. So 1 minus 1 is 0. We have the 0.30. Did everybody follow what I did there? Just subbed in 1 into the function. Did f of 1. I mean f of 3. Okay, so, all right, square roots. Notice on the top one I did 1, then I went to 4. So I went 1 away from the vertex, then I went 4 away from the vertex. So the vertex is at 3, so what's 4 away? 7, right? Go 4 away from from 2. Thank you. I'm stuck with that 3 in my brain, right? The vertex is at 2, go 4 away, let's go to 6. So now we're going to do the square root of 6 minus 2 minus 1. That gives us the square root of 4, which is 2. And 2 minus 1 is 1. And we're at the point 6, 1. And look, I can keep going. I can go 9 away from the vertex, which would be an 11. And we'll do one more. And now we got the square root of 11 minus 2 minus 1. Square root of 9 is 3. 3 minus 1 is 2. and I have the point 11, 2. Just stay with me for a moment and watch the board for a moment. Here, I'm going to graph this. Here we go. Right? Because did the A value change? And doesn't A change the shape? So it's the exact same shape. It's just translated 2 to the right and 1 down. Right? It's the exact same shape, the exact same function. 2 to the right and 1 down. You need to get you Geritol or something. Coffee in the morning. You to Starbucks tomorrow morning? What do you get? What do you get at Starbucks? You don't go to Starbucks? Where do you go? Dunkin' Donuts? Do you drink coffee? You do. All right. Cream and sugar? How many creams? How many sugars?
Like 3 creams, 4 sugars.
Did you get any coffee this morning? No, you need some. All right, here we go. So domain, right? Our domains start at 2, correct? The x values, the lowest x value is 2. So we're x greater than or equal to 2. And if you're going interval, bracket 2, comma, infinity, parentheses. And you could do the range. Y greater than or equal to, what's the lowest y value? -1. Oh, greater than. Y greater than or equal to -1. And again, if you went interval, bracket, -1, comma, infinity, parentheses, right? Everybody okay with that? So we translated this function 2 to the right and 1 down. We know how to do this. We did it with parabolas. We did it with absolute value. We did it with other things. Okay, XY chart gets you the values, and away you go. All right, so let's look at the next one. All right, so now we got a couple different things. We got a 2 in front, but not only a 2 in front, we got a negative in front as well. So what does the negative do? Reflected about which axis? The x-axis. So reflected about x-axis. Man, this thing is slow and my brain doesn't see the writing until I'm past. This is weird. And we've got a 2 there. So do you think 2 will make it go up more steeply or less steeply? What would you expect? It's a multiplier of everything, so more steeply, right? It's multiplying the output, right? So we're going to expect more steeply. How would you start a problem like this? You'd start with the vertex. Don't miss that. Those of you that are going to struggle tonight, you're going to struggle because you're not going to start with the vertex. You got to start with the vertex. And what are the coordinates of the vertex? -1, 4. Because again, this is technically an x minus a -1, right? Just like parabolas, no different. Just like absolute value, just like everything else we've done. When you do ellipses and hyperbolas, exact same thing. Circles, same thing. All right, x. So let's graph our vertex at -1, 4. Right there. XY chart. Now again, important where you start. I want everybody to think what x value you would start with. Don't say anything yet. Everybody think what would be your first x value for your XY chart. Got something? All right, on 3, tell me your answer. 1, 2, 3. 0. Now, some of you weren't thinking. That's not good. Or you were thinking and didn't know what to do. All right. We can handle that, but you better ask questions. Because if you don't know that, you're in trouble already. Because you got to be orderly in your values. So we're going to start at 0. We're going to do now the function with a 0 in for the variable. Square root of 1 is 1. 1 times -2 is -2. -2 plus 4 is 2. And we're at the point 0, 2. Oh, it's looking steeper already. And again, remember, we're expecting it to be reflected, right? Okay, our first value was 1 away from the vertex. Our next value has to be how many away, or we want it to be how many away? 4. You can do the other stuff, you're just going to have decimals. I mean, you can. You can do other numbers, there's just going to be a bunch of decimals, which is fine. But it's a little bit easier if we go 4 away. So we're at -1, so 4 away is 3. So again, we're going to do the function with the 3 where the variable is. 3 and 1 is 4. Square root of 4 is 2. 2 times -2 is -4. -4 and +4 is 0. So we're at the point 3, 0. Let's do one more. So again, we know the square root of 1, that's why we go 1 away. We know the square root of 4, that's why we go 4 away. And the next one we know is the square root of 9, so we go 9 away, right? And we're at -1, and 9 away brings us to 8, right? -2 times square root of 8 plus 1 plus 4. Square root of 9 is 3. 3 times -2 is a -6. -6 and a 4 is a -2. And we have the point 8, -2, which is right there. We are now ready to do our function, right? Now remember, we're translated 1 to the left and 4 up. So maybe reflected about the x-axis isn't maybe the best term. Probably this, reflected about y equal 4 would be the better way to say it. Those of you that understand y equals 4 is this line right there. Because again, we're shifted up 4. That up shift does that. Hunter.
Should we always have around 4 points when we're graphing values?
Yeah, it's usually nice. But again, if you use 0, 1, 2, and 3, then you're all stuck right there, and those aren't the greatest 4 points to use. Alex.
So will these ever point to the left?
Sure. I think the next one might. All right, I'm not going to do domain. Well, let's do the domain and range real quick. So x is greater than or equal to -1. Right? X values from -1 on. So if you were to do it, bracket -1, comma, infinity, parentheses. What would the range be here? Y is less than or equal to 4, right? Which in this case, it's parentheses, -infinity, comma, 4, bracket. Intervals always least to greatest. Least to greatest. So for when it goes negative, you got to say -infinity first, then comma 4. All right, second page. Elias.
Why do we write the domain range? What's the purpose of it?
The purpose of that is so an individual understands what the possible x values are of a function and the possible y values of the function. These are the only possibilities. So in real life, if this were a real life situation, x cannot be anything less than -1. It is not possible. Those values aren't relevant. Y cannot go above 4. That's the highest it can go. It can go all the way down to -infinity. And it depends upon what the function represents, and it could represent a myriad of things. But these are the only possible values. There are no other existing values besides an x greater than or equal to -1 and a y less than or equal to 4. Only possible. All right, D. Now we got a negative inside the radical. This is reflected about x equal h. Reflected about x equal h. All right, what's the vertex here? What's the vertex? What's the h value? 0, and the k is -3, right? So we have a vertex at 0, -3, right there, right? Right there. X and y axis, 0, -3. And we are reflected about this line. X equals 0 is a vertical line through the x coordinate of 0. Okay, that's important to know. But look, if you didn't know it and you tried to use 1, you're going to get the square root of -1, and you're going to say that's imaginary. So we got to go the other way. So we're going to start with -1. Minus a -1 is a positive 1. Square root of 1 is 1. 1 minus 3 is a -2. I got point -1, -2. I'm going to go 4 away. -4. Negative and -4 is positive 4. Square root of 4 is 2. 2 positives and 3 negatives leaves me 1 negative. -4. -1. Then we'll go 9 away and do -9. Square root of 9 is 3. 3 minus 3 is 0. And we get the point -9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. And on this one, we are going like this. And we are reflected about x equal h. So again, your domains, be careful. Your range, be careful. Domain, parentheses, -infinity, comma, 0 bracket, right? Or x less than or equal to 0. By the way, let's go back and fix this one up here, the reflected. This is really reflected about y equal k, right? It's a better way to say that instead of the x-axis. Y equals k. All right, one last one. So what's going on in here, and what do we have? So it's hard to read what's going on in the format it's in right now. And you might say, well, let's switch the -x and the 4 and make it -x plus 4. But you'd be missing the point. Let's instead do this. Let's first swap the order. So I put the -x in the front and the 4 in the back. But before we really finish anything off, we should factor out that negative. Okay. So what is this reflected about? Reflected about x equals what? Come on, read it. Just look there, read it. Reflected about x equals 4. And the vertex is at what? 4, -1. Say, I wouldn't have known to do that. Yeah, I know. That's why I'm showing it to you. See, that negative has to be a multiplier of the whole radicand to be able to truly read the value of h. The first example, it was a 0 and it didn't matter, right? In the second example, we've got more to the radicand and it does matter. So that negative's got to be factored out, and now you can read h and k clearly. So on this one, we got a vertex at 4, -1. 1, 2, 3, 4, -1, right there, right? 4 to the right and 1 down. We got a 2, so we know this is going to go up a little bit more steeply. And we're going to go from there. So again, it's a square root, so I want to be 1 away. I'm already at 4. Let's use 3. And you can put it in either form. You can put it in this form, or you can put it in this form. Negative 3 plus 4 is 1. Square root of 1 is 1. 1 times 2 is 2. 2 minus 4 is a negative 2. So we're at 3, negative 2. That's bad. That's wrong. Let's do that again. What are we at? 1 times 2. Oh, that's a 1 out there. If I could read my writing, I'd be in good shape. So what do we end up with? A 1, 2. 2 minus 1 is a positive 1. All right, much better. So we're at 3, 1. 1, 2, 3, 1. Now I want to go 4 away from that point. I'm at 4, so 4 away is 0. That's just a 0. Square root of 4 is 2. 2 times 2 is 4. 4 minus 1 is 3. So I'm at the point 0, 3. And again, I'll do one more. 9 away from that positive 4. So that would be a negative 5. Hey, be careful. Negative and negative is a positive. 5 and 4 is 9. Square root of 9 is 3. 3 times 2 is 6. 6 minus 1 is 5, and we're at the point negative 5, 5. And it's as we expected. It's reflected about x equal 4. It's steeper than a norm, and everything's as we would expect. I'm just going to do the domain and range and intervals, parentheses, negative infinity, comma, 4 bracket, right? Possible x values, possible y values, bracket, negative 1, because it's going from negative 1 up, comma, infinity, parentheses, right? The left one is x less than or equal to 4. The right one is y greater than or equal to negative 1. All right, be careful. Quiz tomorrow. We'll review on Thursday and test on Friday. Jeff? Because when you factor out, you got to take a negative out of this and a negative out of this, which means you got right. Because if you multiply it back out, you get negative x plus 4. So you got to change the sign of all the things you're factoring a negative out of. Good question.